Hello friends, welcome back to the channel. My name is Desmond, final computer science student from University of Malaya. In this lab, we will talk about how to build a half-adder. So a half-adder takes in two inputs, A and B, and output two outputs, S and C. So if A and B are zeros, then the sum and carry, which are S and C, would be zeros because 0 plus 0 is 0. If A is 0, B is 1, then the sum should be 1 without any carry. So the carry is 0. For 1 plus 0, the sum would be the same. It's 1 and without any carry. If 1 plus 1, then we would get a 1, 0, which is 2 in binary. Right? So this is the half-adder. So it will take in two inputs, or we say two binary numbers, and it will output the sum of the two binary numbers. Alright, so I hope you understand what we're trying to build here, the half-adder. So yeah, let's move on to the next slide. So what chips do we need for this exercise? From this box over here, we can see that we would need a XOR gate and an AND gate. If you remember from lab 1, we have found that this chip LS136 would have XOR gate inside, and for LS08 they would have AND gate inside. So we would need two different chips for this half-adder. So one chip would be LS136, another one would be LS08. So this is what we would do. So we are going to have VCC and ground, of course. We are going to have also an LED to show the output for S and another LED to show the output for C. So of course the LED would need a resistor in order to lower down the current so that we don't burn the LED. In order to power up this chip, these two chips over here, we would need to connect the VCC to the VCC terminal of both of the chips, and we would need to connect the ground to ground of both of the chips. Okay, and we would have A and B, right? So let's say A is over here and B is over here. But let's connect the output first. Let's say that for this XOR gate, we use this part over here, and for this AND gate, we would use this part over here. We would need to connect A to both inputs, so A to one of this chip and A to one of this chip. Similarly for B, we will need to connect them to these two inputs over here. Let's use a different color. So B, we will connect them to 2 and 2. And then for the output, so the output of the XOR gate would be S. So let's connect number 3 to S. We would need to connect it to the positive terminal. And for this, also number 3, we would connect it to the C, because the output of AND gate is a C. And then from the negative terminal of the LED, we will connect them to a resistor. And then from that resistor, we will connect to ground. Alright, so this would be our circuit. And for A and B, in order to simulate 1 and zeros, we could connect them to VCC and ground. So if we want A to be 1, we could connect them like this. And if we want B to be 0, we could connect them like this. So B could also be connected to VCC to simulate 1, and A could also connect to ground to simulate 0. Let's see how would we connect them on the breadboard. So for VCC, usual, we will connect them to one of the lines over here, and for ground, we will connect them to this. And then we would power up the chips by connecting the VCC terminal of the chip to our VCC line. And then this chip over here, we do the same over here. Okay, then for the ground, same thing, connect them to here, and ground, let's connect it to this line. And before we go on, we would need to connect this part over here because it's empty. So let's use a jumper wire to jump from here to here, and for the red as well, we would use jumper wire to jump from here to here, so that this whole line is connected. Alright, then the next thing we would do is to connect the inputs and output. So let's say we connect A to 11. So both number 1 will be connected to row 11, and then B, we will connect them to, let's say, 14. Okay, now for the output, let's use a different color. We will connect them to the LED over there. So this is for the XOR gate. This is for the AND gate. Right? So remember that the XOR gate is outputting a S, and the AND gate is outputting a C. So don't remember that the output of the XOR would connect to S, and the output of AND gate would connect to a C. From the LED, remember to connect them to the ground. This is our A, and this is our B. And there are two wires from here. So A can be connected to either this line or this line, and B can also be connected to either this line or this line. If we connect both A and B to the ground, so 0 is ground and 1 is VCC. If we connect both A and B to ground, so these two lines, A and B to ground, then the output we get should be 0 and 0, which means that these two light bulbs should not light up. And if we connect the B to 1 or A to 1 and the another one to 0, then we should get this as lights up and no light for the C. And if we connect both A and B to the VCC, then we should get this LED to be turned off and this bulb emitting light. Okay, this is the HalfAdder, and when you have done this lab, you could move on to the FullAdder. So the difference between a HalfAdder and a FullAdder is that a FullAdder has an extra input called Cin. So Cin stands for carry, input. So instead of adding 2 binary numbers in HalfAdder, we are now adding 3 binary numbers. Okay, so let's say A, B, and C are all zeros. So 0 plus 0 plus 0 would be 0. If let's say 2 of the inputs are 1s and the other another input is 0, we would get 1, 0. So this is the S and this is the C, right? What if 3 of them are 1s? Then in this case, we would get a 1, 1. So this is C and this is the S. So this is the example for the FullAdder. And in FullAdder, if you notice, there are 3 different types of gates. So this is the XOR gate, and this is the AND gate, and there are one more extra gate over here, which is the OR gate, right? So for the FullAdder, you will need 3 different chips. So to find out which chips you will need, remember to look back at your Lab 1 submission. So from there, you would know that which chip contains the OR gate. Then you would use that OR gate to complete this lab. So thank you so much for watching. If you think this video is helpful, remember to subscribe, like, and comment down below to let me know, also to share it with your friends. And this kind of videos took me a lot of time to do, so if you'd like to buy me a coffee to do more videos, you could go to buymeacoffee.com/dio or paypal.me/dio123 in order to support me. Hope to see you guys in the next video where I will be talking about building a circuit for flip-flop. Thanks so much for watching, and bye-bye.